Now, welcome to my talk. Thanks for taking your time. For Micro-Frontends, strive for fully verticalized systems. One disclaimer in the beginning, I'm not an American Indian, right? I'm just an Austrian guy who did totally underestimate the sun here in Greek. So that's why I'm so red and I cannot really move because everything is totally hurting, but I will somehow make it. So, first things first, my name is David Leitner. I'm working as a lead developer, technical expert for a consulting company called Core Technologies, which is based in Germany. So most of the projects I'm working in are in Germany, but I'm actually from Austria, Vienna, so I still live there. So that's about me. I do a couple of things around the community. I think we all should do this. We have the pleasure to work in a really fantastic community as software engineers. The best I think we could have. So who knows about microservices? Can you raise your hands if you heard this term already? Okay. Some of you, that's good. Who uses them? Who uses them really in production? Okay. Who regrets to use them? That's clear. I would have loved to start this talk with a classical definition about micro-frontends. You know, some kind of Wikipedia definition, what are micro-frontends, why should we use them? But as usual, in software engineering, we don't have a real common understanding about this term. We have terms where we really don't know actually what they are, and we are speaking from different things. So if I speak to one of you who uses micro-frontends, I'm quite sure that he has a total understanding about what he means with micro-frontends than maybe I have. But at least there's one definition I like, the one from Michael Gears, because it's pretty simple. What he says is that the idea of micro-frontends is to extend the concepts of microservices to the front-end world. And I like this definition because it's super easy and super simple, as mentioned, because what does it say? It just says take all the advantages from microservices, move them to the front end, and have them there. We all know how good this usually works if we do things like this, but let's keep it like this for now, okay? So the idea of micro-frontends is to move the concept of microservices to the front-end world. Because this is how our blueprint architecture usually looks like, right? So if I go to clients, this is what they're doing. Everybody's doing microservices these days, that's okay. In front of those microservices, we usually have some kind of single-page application, Angular, React, Vue.js, whatever you like. And in between, we have some kind of gateway, right? So this is how it usually looks like. And the first secret, I will tell you a couple of secrets during this talk. And the first and maybe most important secret is that in 80% of the cases, that's fine, right? I really don't want that somebody is going back on Monday to work or to his project and said, hey, you know, I had this great talk about micro-frontends from this great guy. And we should now do micro-frontends. In 80% of the cases, this blueprint architecture is just perfect as it is. So the rest of the talk will be for the rest of the 20%. Right? And I'll tell you a second secret. I'm in the mood of telling secrets today. In 80%, also this is fine, right? But I'm not here to blame microservices today. Not today. I've done this a couple of times already. So let's assume that we are doing microservices for the right reason. So we have this architecture, right? And if micro-frontends are an idea to move the concepts of microservices to the front-end world, we just need to rewind a little bit what microservices are and why we actually use them. And the idea of microservices, it's massively hard to go around here. Do you hear this? Oh, shit. The idea of microservices is actually, or the definition of microservices is quite clear, right? There was this great book from a great guy called Sam Newman. Who knows the book from Sam Newman, Building Microservices? Okay. Oh, that's not too many. If you do microservices, you should read it. It's really a good one. And he has a clear definition about microservice. Oh, shit. Okay. I'm too far away, so I have to stand here. So Sam Newman says, microservices are small and focused on one thing. And we do them because we want to be autonomous, right? That's it. So end of story. So even the definition of microservices is micro. So the question arises, why do we want to be autonomous? And there are roughly 6 reasons why we want to be autonomous usually. The first one, the most obvious one, we want to have independent deployments, right? That's what we all know about microservices. We do them because we want to shift our services independent to production. We want to shift service A today and service B in 2 months again. That's why we do this, because we have those independent deployments. The second one is we have distinct operations. So our services start on their own, they run on their own, they die on their own, they restart on their own, right? And they have their own persistence, so they can run totally autonomous. The third one is that we can be technology agnostic. I think it's important to stress here that we can be, right? Doesn't mean that we have to be, but actually it's a really good thing that we can build services and tools, frameworks, programming languages, which fit the problem we tend to solve best. So this is, at least for me, a huge improvement we got by microservices. And not only internally we are technology agnostic, not only in our service, but also to the outside world. So microservices brought the big advantage that we mainly trust in standardized and even open source tools around our microservices. So we communicate over HTTP, we don't have those proprietary protocols anymore. So being technology agnostic was a big move from microservices. We have small interface surfaces, so we have a clear defined boundary between our services. We expose a well-defined amount of functions. We have some API endpoints, so it's clear how we talk to these microservices. We can model around business domains. This is actually a topic we could talk for hours, but the whole DDD, the domain-driven design era, was restarted again by the introduction of microservices. People started to build services around business domains and to build teams around business domains. And last but not least, the most important one, this is how we sell it to the business usually, right? So we build tons of software each day, right? Software eats the world, software is everywhere. So we need to parallelize this stuff, what we are doing, and microservices are usually a good way. That's why most of the companies are actually doing them. Okay? So if we go back to this blueprint architecture, we will then find out very quick that if we take a look at the front end, we lose most of these advantages. So we lose most of these advantages I currently presented to you on the front end layer. So let's go through them again quickly. We don't have independent deployments here anymore, right? We deploy our front end monolith or we don't deploy it. 1 or 0, there's no in between. And this can be a big issue. If your front-end application is growing bigly, you need to work with feature toggles, you need to work with high sophisticated branching technologies or strategies, and this is usually a pain. So we don't have independent deployments on the front end. We are not distinct in operations. So if our front end fails, actually, or if one part in our front end fails, usually our whole front end fails. And I have this joke, Actually, I came from a backend area. I was doing Java and .NET for years, and somewhere in the last 5 years, I was moving to the front end more and more. And so 70%, 80% of the code I'm writing these days is JavaScript or TypeScript, or this whole ecosystem. And I can tell you, even if I write a lot of JavaScript code these days, it's still very easy to create errors in your JavaScript code. And people then always ask me, David, why did you move to the front end world? How can you like JavaScript? And I said, yeah, well, I like it. That's the first thing. I never thought that I would say it one day. I like JavaScript, but it's hard. It's still hard. It's still a hard language to create stable code. And I say to them, yeah, sometimes I have the feeling if I write code, I say, I really don't like this language. I really hate this shit, right? But when I say I hate this shit, and I'm writing JavaScript code, and I say I hate this shit, then I usually have the issue that I don't know what this refers to, right? So this is the thing with JavaScript, and distinct operations would especially be important if we have non-typed and non-compiled languages usually, right? But we don't have them. And we are not technology agnostic. And I was at the NG-Conf, I think in 2013, it was in Paris. I'm not sure if it was 2013 or 2012, doesn't really matter. This was the biggest Angular conference back then. And I was there, and there was a keynote from engineers from the Angular team. And everybody was looking forward to this keynote. It was called something like the future of AngularJS. And everybody was expecting big news. And then we were sitting in this conference room. It was somehow as big as this, I guess. And those two Google engineers came to the stage and said, you know what? AngularJS is somehow built up on old standards. We cannot really support this anymore. We need to come up with something new, and we just will call it Angular. It will be a total new framework. And everybody was shocked. I was shocked because we started a couple of big customer projects with AngularJS, and I said, oh my God, how should I tell them now that this is actually legacy already, what they started to introduce a couple of months ago. And there were two interesting things for me when those Google developers said this. The first one is actually not even Google, which has massive manpower and has massive smart people working on this framework, is able to keep track with how fast the web platform was moving back these days. And the second thing, I mean, the main business of Google is still search engine, right? Besides selling our data, it's still search engines. And I would have expected more from a company which's main business is search engines, instead of renaming it Angular, to mess up the search results for the next 2 years. I would have expected more cleverness from Google here, but it's fine. But being technology agnostic would have really been super cool here. Would have been really super cool here. And many companies would have not been so afraid to move to single-page applications the last few years if this whole AngularJS thing wouldn't have happened. We don't support small interface surfaces. Somehow clear, we build one huge application. We do not support parallel development. And this is usually when people feel the pain. This is when they come to us and say, hey, David, how can we slice this smaller? Because, you know, we have a single-page application. We have 5 Angular developers working on it. We move 5 more Angular developers into it, and it's not getting faster, right? So this is what Fred Brooks already said 14 years ago. If you put more people in a project which is slow, it will just be slower. And you cannot make big front-end applications faster at some point in time, and you cannot really parallelize them anymore. And this is where we say, okay, a front-end monolith was born. And then there are those people who say, okay, we need to slice our single-page application into smaller chunks, right? We need to slice them in, let's say, 2 single-page applications, and this is what we call micro-frontends. And this is usually where talks about micro-frontends end, okay? So just slice them smaller, but there's one important question, of course. How do we slice them, right? Where do we put this red line? Anyone having an idea? Okay, well, there are a couple of ways to do this. The first one is to think in real full verticalized systems. So I always use this Amazon domain. I never worked in this domain. I never worked for Amazon. And I never worked in this shopping domain, but I think it's easy to understand and not too complex. So let's say we have a catalog which shows our products, we have ordering which shows our ordering processes, and we have a profile which gives you the profile information, like your name, your email address, and stuff like this, right? So we could say, okay, we take our application and slice it really end to end. So the catalog frontend is bound to a service, the ordering and the profile data the same. And this is what we usually connect them with hyperlinks. So it's really easy. We just build 3 applications, connect them with hyperlinks, and we call this hyperlink connected applications or hyperlink approach. And if we do this and take again a look at the bullet points I showed you before, we now find out that we have independent deployments, so we can deploy our stuff totally independent. We have distinct operations, so if one of those applications fail, the rest is still up and running, right? We are technology agnostic, so we can build the first one in Angular, we can build the second one in React, and we can build the third one in the framework of the month. I don't know, Hyper maybe, right? We have small interface surfaces, that's clear. We just have hyperlinks between our applications. We can model around business domains, and we can finally parallelize our development, right? But this approach has one fundamental issue. It is based on the assumption that we can have fully verticalized systems, right? And everybody who's working in more than 24 hours in software engineering usually knows that's not really possible, right? And a good example, usually not really possible, is a dashboard. So on a dashboard, you usually want to show the latest. You want to show the orderings you did, and you also want to show your profile, right? So we need to aggregate all this stuff together. And this comes with 2 fundamental issues. The first one is overfetching. Who knows about overfetching? Okay. So let's assume we have a profile. We have a profile service, and this profile service returns a profile with 50 fields, right? First name, last name, I don't know, all this stuff you have in a profile. But on a dashboard, you actually just need the first and the last name, right? So you fetch 50 fields, but use 2 of them. So it's totally useless. It's total waste of traffic, right? So this is what we tend to call overfetching. And even worse, over-requesting, right? Over-requesting is especially a problem if you build REST APIs. Let's say we have a profile again, and we have shopping groups. So you go to the profile service, say, okay, give me all the shopping groups, then you get IDs of the shopping groups. Then you need to fetch each shopping group on its own to get the name of the shopping group, because this is what you usually want to show. And this is what we tend to call over-requesting, sorry. And again, Sam Newman came in place and said, okay, we can solve this issue easily, and introduced this backend for frontend pattern. Who uses the backend for frontend pattern? Sorry? Nobody? Okay. No frontend for backend users here. Nobody has this in his architecture. Okay, one guy. Cool. And the idea of the frontend for backend for frontend pattern is to actually exactly solve this problem, right? Because we now have those additional microservices which are very bound to the application, to our front-end application, and they do the aggregation, right? So they fetch all the data as we need it and bring it to the user or bring it to the front-end application in the model how the front-end application expects it, right? Because those microservices are usually very generic. Those are domain services. We want to reuse those services. So we build very generic APIs that we can use them in different contexts. And this, as mentioned, usually causes overfetching and over-requesting. And those backend for front-end services are very consumer-driven. So the consumer actually says how this application, how this API should look like. That's why I painted it here in the same color as the front end, because it's somehow part of the front end, even if it's... Oh, okay. Even if it's running on the server, it's still somehow part of the front end. And very important when it comes to backend for front end, but if nearly nobody is using it, I think the pain is not so big. Very important is that we just put the right stuff into the backend for front end. So if we think of application logic, and this is very abstract, I know, and very simplified, but usually we have 4 things we tend to call application logic. We have data logic, which goes to the database and saves to the database. We have domain logic, which, for example, calculates the current age of a person based on the date of birth. We have a process flow, which says, okay, we go to this service, we go to this service, we get data from this service. Based on this data, we go to this service. That's flow logic. And last but not least, we have presentation logic, which brings our models in a shape that we can render it on the front end. And it's fundamental and very important that we only put presentation logic into this backend for front ends, because otherwise we will have a lot of duplication between this backend for front ends. So no domain logic, no process flow logic, just stupid and dumb view aggregation. That's really important. A more modern approach for backend for frontends is what we tend to call GraphQL. So I see a lot of clients moving to GraphQL now for the backend for frontend layer. The big advantage of GraphQL is that it actually forces you to only put presentation logic into this backend for frontend layer, because it's very opinionated. Yeah. So process and especially data logic is very hard to put into a GraphQL layer. Good. And I like this approach, honestly. I like this approach of having backend for frontends, fully sliced applications, right? Because usually I tend to say the more coarse-grained you can go, the more coarse-grained you should go. I think this is very important. I always say this to my clients. If we talk about microservices or micro-frontends, and I tend to describe it in my own words, I say, think big, right? Think big if you design your services, and the same is true for the frontends. It's much better to wake up with a little bit too small microservices than to wake up with pico or nano services. So in this case, think big, but, and you know, if you hear but, all you heard so far, you can forget it, right? I mean, it's not the case here. But there is a but. There is a big but with Hyperlink integration. And this big but is that Hyperlink integration breaks your single-page applications, right? That's somehow clear, because single-page applications don't want to have these round trips all the time. Single-page application is a total different concept. You fetch it once and you stay on your client, but with Hyperlink integration, of course, you have all these server round trips. And a good example And a good example where Hyperlink integration breaks your single-page applications is usually Amazon. So this is the German Amazon page, but I think the Greek one would look somehow similar. On the left-hand side, we have the product page, where you can search for products, go to products. On the right-hand side, we have the checkout page. And if you look at this page, you will find out that it's a total different application. It's total different when it comes to UI and UX, and it's also total different how the flow and how the UX patterns are integrated in those applications. So for Amazon, it was okay, because they said, okay, we just have two actually total different applications which are developed by total different teams which can deploy it independently, and we'll just link them together by a hyperlink. But especially for UI and UX, this is usually an issue. But this is not the only one. There are a couple of other issues when it comes to hyperlink integration. The first one is that we add an horizontal layer here, right? And we all hated horizontal layers a couple of years ago. We said we don't want to do this horizontal layering anymore. We want to go for verticals more, because if you change something here, you need to change it here, and you need to change it here. And this is what we call the ripple effect, right? And if we add those horizontal layers now to our microservice architecture, we bring exactly this ripple effect back again, right? And this can be an issue, and this can slow down your performance. But that's the smaller issue. The real big issue is that we don't have those verticals anymore, right? So if you change the ordering service, you also need to change a couple of other services. So you don't have these verticals which we spoke about in the beginning anymore, right? So let's think of this, and let's maybe take a step back, yeah? I mean, not you sit, but imagine to take a step back, right? And if we have a total greenfield solution space, right? If we can think, how could we maybe do this, right? My favorite approach is to do it like this, right? We have a dashboard service which returns a dashboard UI, okay? And then we have a profile service, and this profile service returns a profile UI. And we just plug this profile UI into the dashboard. But it's totally independent of the dashboard. And the same goes for catalog, and the same goes for ordering. And this raises the question, how do we slice? And that's why I said in the beginning, we don't have a real common understanding of micro-frontends. Because on the left-hand side, you see this hyperlink integration, and it's fine. This is a good approach very often. Huh? I don't tend to call it micro-frontends. For me, it's just linked applications, but I'm not religious about this term. But on the right-hand side, you see multiple micro-frontends per page. And this is where it is getting really interesting, in my opinion, right? So if we go for the right approach, how do we integrate them, right? How do we integrate those things into one UI? And as usual, again, there are a multitude of options. And I think this is the most complex slide I will show you today, so give it maybe a minute. So what do we have? We have a repository of 3 micro-frontends. Let's say we have 3 micro-frontends, right? So they live in our repositories. So the first and most simple approach is that we take those micro-frontends, bundle them together during build time, and ship them as a monolithic deployment, right? This can be done. This is how people tend to do this. A second approach is that we again have these 3 micro-frontends, we build them independently, and once our clients hit our services, once our client request hits the edge service, we say, okay, you want to have this page now, I bundle together my micro-frontends and will return you one application. And the last but not least approach is runtime integration. So we build our micro-frontends independently, we deploy them independently, and we provide some kind of aggregation UI. People tend to also call them app shells, but app shells are a little bit overused because they are mainly in the progressive web page area. So I tend to call them aggregation UIs, and those aggregation UIs actually collect the front ends they need on the client side, so during runtime. I will take a look at all of those 3 now with you to line out a little bit the advantages and disadvantages. So build-time integration is the easy one, in my opinion, because we have monolithic deployments, and monolithic deployments usually tend to simplify things when it comes to operations and error handling, right? And runtime integration is often seen with monorepos. Who uses monorepos? Who knows what this is? Okay, that's quite familiar. Monorepos is a very strange sounding idea if you hear it the first time. The idea of monorepos is to put all your application in one single repository, in one single Git repository, right? Why do we do this? Because people often come to me and say, David, why do we do, especially in the front-end area, so many monorepos? We don't have them on the back-end services. We just do this kind of monorepo stuff in the front-end. And the fundamental difference between the front-end and the back-end is usually reusage, right? So also in our microservices, we maybe have some kind of common lib where we have error handling or locking, but it's very tiny. We don't want to share a lot between our microservices. But in the front end, we have this issue. I mean, it's not an issue, but for developers, it's sometimes an issue that one customer expects one company to have one experience, right? And this makes it hard, and forces us to have a lot of reusage in the front end, because even if the front ends are getting more complex and complex, we put more stuff in the front ends, 80% of what we're writing is still UI code. Is still code that creates components the user will see at the end of the day. And if we want to have consistent UI, of course, we need to share this code somehow. And this is why monorepos are such a success story, I would even say, in the front-end world, because if you put all your stuff into one repo, reusage is really easy. If you have a button, you don't need to push it to Nexus or NPM first and need to fetch it everywhere. You just change it on a single place and can be ensured that all the applications have this changed button now without changing any upstream dependencies. So the first one is simple reusage, so they allow extensive sharing and reuse. The second one, which is also kind of strange if you hear it the first time, is that a monorepo usually has one dependency file or one dependency definition file, in JavaScript mainly a package JSON. So there's one place where you define your dependencies. There's one place where you say, okay, I want to go with this React version or I want to go with this Angular version. And this is just a precondition again to allow easy reusage. Because if you say, okay, every application in this whole repository is based on Angular 8, right? Then you can easily reuse code. Because you can be sure that the button you build will work on all the applications because they are all on the same Angular version. And many companies, Google, Facebook, tend to use these monorepos, and also lots of the clients I'm working with use those monorepos. And there's quite good tooling if you want to go this approach. There's NRL, which is called the NX console, which allows you to do monorepos now also for React and Angular application, and even Nest.js, so Express.js in Cool. And this allows you to also put your backend for frontends, for example, into this monorepos. As I mentioned earlier, the backend for frontend is part of the frontend application, so it's a good choice to put it also in this repo to, for example, share models between the applications. And the second one is Angular workspaces. So with Angular 6, we got this workspace feature, and this is also a good fit if you want to go with monorepos. So this sounds promising. If we take a look again at our bullet points, we don't have independent deployments yet. That's clear. We build it once and deploy it all together. We don't have distinct operations. If something fails, it usually will fail for all the other applications also, and we are not technology agnostic. I mean, that's the whole idea of monorepos, to not be technology agnostic, right? But we have small interface surfaces, so we have really 3 dedicated applications. And these monorepos usually also come with tools where you say, okay, I don't want to have dependencies between these applications. I don't want to have application A a dependency on application B. So you can really make this quite transparent and clear that you want to have totally independent applications, so totally independent React applications. We can model around business domains, and we can support parallel development here. So that's actually a good fit if you don't have any issues besides that you cannot really increase the speed of developing your front ends. But maybe we can find even a better solution. So let's jump to the next one. Let's jump to server-side integration. So the most popular framework I know these days for server-side integration is the Taylor project from Project Mosaic. So this was introduced by Zalando a couple of years ago. I think it's still not so wide used, but it's a quite interesting approach. But nevertheless, all those approaches you will find for server-side integration are actually based on the quite old technology, which is called server-side integration or edge-side integration. How does this look like? It looks usually like this. This is server-side includes. So you will have some kind of HTML, which is, of course, rendered on your server. And then you have those includes. And every include goes to another microservice, which returns again another fragment, which you will just plug into this HTML. So you can slice your application here on the backend side. And this is done, server-side includes, as they are here, in all their simplicity, are, for example, done by IKEA. So if you go to the IKEA page, you will see that you have, that it has a lot of round trips, and that it is based on this idea. And we have two issues here, again. First of all, JavaScript and CSS is global scoped, so it's maybe not a good idea to put all your applications into one big applications, because you can have somehow strange side effects, especially with CSS, but also with JavaScript. And the second one I already mentioned is that you have a lot of round trips, of course, because you always need to go to the server again. So again, you break your single page application somehow. And as I mentioned, if you go to the IKEA page, you see this really clearly that they do all the server round trips all the time. But for them, it worked out, and that's the most important thing. And then Zalando used actually those technologies and made them a little bit more high sophisticated. So they came up with Tailor, which is a layout server. So they tend to call it a layout server. You can think of it as an edge service. So if you have a request to your application, Tailor will go and say, okay, this route, interesting, I will match it to a template. So they have this definition of templates, and you can define templates. And these templates usually consist of fragments. And those fragments are a little bit more sophisticated than classical server-side or edge-side includes, because in this case we can see, okay, the catalog, for example, has a primary attribute here. And that's quite neat, because if the catalog microservice will return a front-end fragment with a status 404, because maybe the product is not found, 404 product not found, this HTTP status will then be used for the whole application. So it's the primary fragment which, for example, defines the HTTP status and a couple of other things. And the account has this async attribute. And this one ensures that if the account is not loaded yet, we will still return the application and will asynchronously load the account fragment later. And it also has a fallback. So if the account domain service is not available, not reachable for whatever reason, you can add here a fallback source, and this is usually a static page somewhere on a S3 packet, which is never down. And this one shows then, okay, the account service is not working, or it just shows some static information about your account. So they have a lot of additional things which Tailor brings that make it really useful in practice. But the important thing is all those fragments are really microservices, right? This template just collects the fragments of microservices, aggregates and bundles them together, and returns them as a single page. Tailor supports JavaScript isolation. That's one of the selling points, at least in the past. It was one of the selling points. How do they do this? Because people tend to think there's some magic going on, but it's really simple how they do it, right? A fragment usually consists of HTML, a script, and styles. So it's always a bundle. A fragment is always a bundle of those three things. And they did a neat trick to ensure this JavaScript isolation. They just say, okay, the script is wrapped by a function which is called init, and this init function just gets the HTML as the input parameter, and so you cannot break out. You can only modify the current HTML you're working on. And the second one is about CSS. Who thinks that CSS isolation is possible? One guy. It's interesting. Yeah, I ask this question a lot, and people always say, no, CSS, not isolatable. But actually, that's not true. CSS, in my opinion, was never the issue. CSS can be isolated since a couple of years. It was always about JavaScript where we had the real pain and the real troubles. Because CSS, back then, we had something like BAM. Who knows BAM? BAM. Okay. I learned BAM back in the days, and it was really a mess, because it's actually a naming convention, how you name your stuff, that you don't have duplicated classes. And I really didn't like it, so the good thing is we got much better opportunities now. We have style components, mainly in the React world, very cool. Written actually by a Viennese developer, so we're very proud of this. And the second one is CSS modules. And CSS modules are more in the Angular world, so Angular is not directly using CSS modules, but actually the same idea, that they just add some unique postfixes to the CSS classes to make them unique. And last but not least, web components are coming, and web components come anywhere with isolated CSS. Okay? Good. So let's do it again. Let's go through these points, right? So we have independent deployments now. We can deploy our front-end applications totally independent. We build them independent, we deploy them independent. If we want to just change the catalog page, we just deploy the catalog page. We have distinct operations, so all those services, we have seen this in the Taylor example, very good, where we had this fallback URL. If some of those microservices, which provides a fragment, is not available, it's no issue for us. So we are really resilient here also in the front end. We can be technology agnostic. I'm not saying that it's a good idea to build one application in Angular, one in React, and one in Vue.js. Honestly, I don't see big reasons for this, besides that the user must download 3 single-page application frameworks every time he goes to our page. But where it can be powerful is if you work in big organizations where you cannot make those big bang upgrades. Where you say, okay, I want to stay with Angular 6 here, and I want to stay with Angular 8 here. And then it can be powerful to have at least this possibility to step-by-step migrate to new React or Angular versions. We have small interface surfaces. So, as already mentioned, of course, we have 3 different applications. We can model around business domains, and we support parallel development. So this sounds really promising. This sounds really good, and it is really good. I mean, it comes with a lot of complexity, that's clear. I hope this was also obvious from the slides I showed you about Taylor and the stuff. It's not easy. It's not only green here, but it has a lot of complexities we add. But it also comes with a lot of advantages. So let's take a look at the last one, runtime integration. Well, as I mentioned, runtime integration is usually done by something which we call aggregation UI. Okay, so there is an UI which aggregates all the frontends together. What Zalando's Taylor did in the backend before is now done in the frontend. So based on the routing, we load templates, and those templates know which micro-frontends to load from the server. And one of the tools people tend to use here is single SPA. I'm not sure what I think about this, honestly. We've used it now a couple of times. It's quite complex. I'm not sure if it pays off, but there are tools which support you in this, but people also tend to create these aggregation UIs just by scratch, just on their own. And the idea of this aggregation UI is to aggregate all the micro-frontends on a single point. And then there were a couple of smart people who say, okay, this sounds good, but how about aggregating and configuration on a single point? And this is when they brought up something which they call immutable web apps. Does anybody use immutable web apps? Does anybody know immutable web apps? Oh, no one knows this. So everybody will learn something here now. That's good. So immutable web apps are based on the idea of 12-factor apps. Who knows 12-factor apps? Yeah, that's important. These are really important rules if you build microservices. So they were actually created by Heroku engineers to support cloud-native applications, and they're really good. And one thing, for example, they say is that, you know, we build our services and they should be fully independent of where they run afterwards. We build our services fully independent of the environment where they will run afterwards. And one way of doing this, or the recommended way of doing this, is that we say, okay, those microservices, they don't have a configuration connection, database connection string, for example, baked in at build time. They do not know what's their configuration string at build time. And we will give them this connection string by environments variables from the outside. So the environment actually decides how this microservice is configured. And this is one of the core principles of DevOps, right? Build once and deploy multiple times. And lots of 12 points actually are in these 12 factor apps, and one of them was just this one. And the idea of these immutable web apps is to move those 12 factor apps to the front-end world. And this is a quite nice idea in my opinion, because you have this index HTML here, and they see this index HTML as the environment. So everything which is specific must be configured here. So you can see that they have also this notation of environment variables, which are just global JavaScript variables, where we define the API to which we want to go, where we define the gateway and stuff like this. And then we have actually the application bindings, and we define which application we want to use in this environment. So we say, okay, we want to have the catalog application in version 2 and the account application in version 2.1. So you will have multiple environments, but the rest is totally immutable. So this is a really cool idea when it comes to this runtime integration. One last time. Let's go through these points one last time through this same Newman microservice point. We have independent deployments now. Of course we have. We have distinct operations. So the aggregation UI usually takes care that we have resilience. We can be technology agnostic. We have seen there are multiple ways to isolate JavaScript. Web components are one big thing, Angular elements. So we're going in a direction where we can have really totally isolated JavaScript. We have small interface surfaces. We can model around business domains, and we support parallel development. Okay? And if we take a look at this now, this is the same advantages like the server-side integration. So you will ask, okay, which one to use? And this is usually the question I get, because I do this presentation all over from time to time with clients, and they ask me, okay, David, this was nice. You showed us that both of the things are actually equally. Which one should we use? And this is really a hard decision, honestly. I think this is one of the hardest decisions when it comes to this. Which one should we use? Should we use runtime integration or should we use server-side integration? And to make a decision here, it's fundamental to understand that the server-side integration is based on this request-response model we are so familiar with, right? We built applications, web applications for years with a request-response model. You get a request, you return a response, total stateless actually, right? And the interaction between those verticals is then easily done on the backend. So the application state is still held on the backend because your front-end is just request-response. You don't have lots of UI state in your front-end. At the runtime integration, that's totally different. You have a long-living application here. So you have all this state, all this UI state stored on the client. And it's important, it's on the client, right? It's not in your hands. So things can go wrong, and it's hard to find out why things go wrong and what to do if things go wrong. So the vertical interaction is usually also on the front end done. And this is actually the case. If you build long-living applications, if you really need those single-page application benefits, then maybe runtime integration is better. If you want to build stable stuff, I mean, that's nasty to say now. And I said I'm JavaScript developer, but I'm still thinking that the nasty stuff is still maybe better be done in the backend. Then you should go with server-side integration. Cool. Anything that can go wrong? No, nothing. Works? Well, there's a couple of things that can go wrong. Actually, I don't have the time to go in all the horror stories, so if you're interested in the full pain, just have a chat with me afterwards. I'm here for the rest of the day. The first thing, of course, consistent UI and UX. This is the main issue. If you build Micro-Frontends, this is which will hit you, right? So you will come up with component libraries and stuff like this. The second one is shared state. Especially by runtime integration, you need to share state between applications. So how do you do this? There are different patterns. One of them is global redux. One of them is cached API states, different ones. Yeah? Resilience is hard. Resilience is really hard. As we're building distributed systems, we need to care about resilience. Tracing, analytics, offline first, and lots of other things we have not solved so far, right? So really think twice if you want to go into this direction. That's really important. So we've seen a lot of different ways now how we can build micro-frontends. We have actually seen 4. Hyperlink integration, build-time integration, server-side integration, runtime integration. So which one to choose again, right? Again the question, which one to choose? And I always recommend my clients this book. It's sad, but it's really true. It really depends. And it really depends in this case because you shouldn't go for one of them. You should really select the best of all worlds. So you should mix and match. That's how I tend to call it. So let's think again of this Amazon example, right? Where we have a landing page. And this landing page maybe has 80% of the traffic. And then we have a shopping page. And then we have an ordering page. That's fine to just link them by hyperlinks maybe, right? But the shop is maybe still too big for a single application. So maybe runtime integration is a good choice here because it must be very reactive to the user. We want the user to have a very smooth interaction with our application. But maybe the ordering is not so important to be smooth anymore. We just want to be very solid here, right? So maybe server-side integration is a good fit here. So really mix and match. Don't go for one. Try to find, based on your problem, the best mix of different possibilities we have to aggregate our UIs. So the final secret. I'm nearly done, but there's a final secret. And this is very important to understand. I think this is the key message of this whole talk. Micro-Frontends are distributed systems. And this sounds maybe obvious, but it's really, really, really important to understand that if you build micro-frontends, you build distributed systems on the front end. And I, unfortunately, didn't have too much time to go in all the pitfalls and all the downsides. But it's important to understand that we are building distributed systems in the front end. And who knows the one and only valid definition of distributed systems? I will show you. Everything that can go wrong will go wrong, right? That's what Murphy said. So it's maybe better, don't shoot apples now at me, it's maybe better to start with a monolithic first approach. Thank you very much. I hope you enjoyed it.